Okay, let's get started. So this is going to be the continuation of the trig integral, which is method 25, section 7.2. Calculus 2, which is still section 7.2 is the trig integral. So in previous cases, we talked about like the function with sine and cosine. And now we're talking about like a function with the secant and tangent. So we're focusing on the trig product function. Using secant and tangent. Tangent of x. And before I get started, I want to introduce some trig identity that you might need for this part of it in the course. Just like tangent squared plus 1 is secant squared. And the derivative of tangent and secant only to remember, because those are very important when it comes to the trig integral that we will use in like the later course. So there are two cases. So for case 1, it's like even power on secant of x. So case 1 is like even power on secant. So in this case, it's being to pull out a secant square, then use tangent. Then u equal to tangent of x. Because the derivative of tangent is secant squared of x. So we use substitution, actually the trig sub, to evaluate those integrals. So let's try our first example. Is if we have this integral is like tangent of 4x secant of 4x, then dx. You always think, well, they're all in power 4, they're all even power. It's the same strategy, just to factor out secant squared. If only used the tangent sub, write rewrite the secant squared of x according to this identity. Gonna be tangent squared plus 1 secant squared. In this case, is I think some more like a u substitution is yeah, it's more like u substitution. So we like u equals to tangent of x, then du it is secant squared of x dx. Now we construct like a new integral where like the secant squared it is cancelled, and is we write all term in terms of u. The new integral should be u times 4 u squared plus 1, then there's secant squared of x, then secant squared of x du, and you see those two terms vanished. Just the easy integral to evaluate is going to be u4 as u to square plus 1, then du. It's going to be like u6 plus u4 du. And what you and then what you get is going to be 1 over 7 u to the 7 plus 1 over 5 u to the 5 plus constant of integration. And because this is an indefinite integral, so after the integration, and replace u as tangent of x. So the final answer will be 1 over 7 tangent to the 7 of x plus 1 over 5 plus tangent to the power of 5 x dx. So this is what you really can expect to solve the integrals. Like you have even power on the secant. Let's do another one. It's example 2. Evaluate the integral it's more like the Trig sub is like, they just don't forget the Trig identity that you're gonna use. Perhaps we see gonna be pi over 4, and is 0 gonna be tangent squared of x, then secant power to the 4 of x dx. So if you see this kind of integral, and the first thing to do it is rewrite integral with the trig identity, and then do trig sub to u sub, and then just but please note this is a definite integral. So when making any u substitution or any kind of a substitution, make sure to change your upper bound and lower bound. So remain this unchanged. Gonna be secant squared of x, secant squared of x dx. Then just rewrite this whole integral as pi over 4 over 0 gonna be tangent of x times tangent of x plus 1, then secant squared of x dx. Now I'll make the u substitution. U equals to tangent of x. Du equals to secant squared of x dx. And please note that this is a definite integral, so change the bound. So tangent pi over 4 is a 1, tangent 0 is a 0. It's going to be a lower bound. It's going to be u squared plus u squared plus 1 du, and it's going to be 1L u4 plus u2, then du, and what you get is like a number because it's a definite integral. So it's going to be 1/5 of it's going to be 8 over 15. Okay, let's try another one. Example number 3. Evaluate the integral. So this time is tangent and secant squared. So it's even secant. So we just so this is going to be like a harder one, but it's really not. Okay, for this one, just rewrite. Just don't move that tangent squared of 4. Just rewrite this secant of 8. And just you just then just do the whole thing that is same as like the older integral here. And then you just have this whole process. Will be tangent of 4 of x. Secant of 6, here's the trick. Secant squared of x until 3, get the cubic. And then secant square x dx. And then you're just gonna do this, like rewrite the integral. It's gonna be tangent squared of x plus 1 to the cubic, then secant squared of x dx, and then make the sub equal to u to the tangent of x. And then is just expand this polynomial expression. So going to be a plus b to the cubic. So just expand the whole thing. So it's gonna be u to the 4, it's gonna be u squared plus 1 to the cubic. Then du. So this is just gonna expand this polynomial expression, gonna be u to the 6 plus 3u squared. Then it's gonna be 3a squared b. So going to be 4 plus 3 u squared and then plus 1 du, and this is gonna be u10 plus 3u8 plus 3u6 plus u4 du. So this integral it is gonna be u to the 10th plus 3u8 plus 3u6 and then plus u4 du. As we expanded, we're just gonna be 1 over 11 u to the 11th plus gonna be 1 over 3 u to the 9 plus it's gonna be 3 over 7 u to the 7 then plus 1 over 5 u to the 5 then plus constant integration. Because this is a definite integral, we need to replace a term. So the final answer would be 1 over 11 tangent to the 11 of x plus 1 over 3 tangent to the 9 of x plus 3 over 7 tangent of 7 of x, then plus 1 over 5 tangent of 5x plus constant of integration. Wow, this is a long integral. Okay, let's I think it's gonna be the tangent of x. So let's try some like smarter. Let's try like another hard example. Let's example 4. So it's gonna be evaluated the integral. Okay, let me sine over 4 over 10 over cosine of a 10x dx. Well, this thing's like it seems complicated, but once rewrite with the trig identity, just some algebra trick, you're all gonna know how to solve this integral. So sine over cosine is a tangent. So it's just the hint. with the tangent of x. Equal to sine x to the fourth over cosine to the fourth x times 1 over cosine to the 6x dx. This turns to the tangent to the 4. This is, for this, we just swap this, the thing, just gonna be secant to the 6. So when you see this kind of a messy integral, don't just try to feel like, oh God, that I'm afraid of this. There's only gonna solve the integral, so don't worry. So this messy function turns into the tangent of 4, and then secant to the 6 dx. Wow. And then use like the u sub is like, and rewrite this integral to like tangent to the 4 to the x and secant to the 4 of x and secant squared of x dx. And if you and then this is gonna be tangent to the 4th to the x, gonna be tangent squared of x plus 1 squared secant squared of x dx, and do the u substitution, the trig sub. And you were just gonna see for the u substitution. I'm just gonna do this u sub here. You're just gonna get u4 times u plus 2u2 plus 1, expand the expression. So you will get integral like u8 plus 2u6 plus u4 du, then do antiderivative. And what you got gonna be 1 over 9 u to the 9 plus 2 over 7 u to the 7 plus 1 over 5 u to the 5 plus constant of integration. This is a definite integral, so you just needed to replace the term, then you're finished. So that sounds fun, right? It's all going to solve it. Don't be afraid of anything. So integrals are like, so integrals like once you know the trick, and you just can solve many integrals that you cannot solve earlier. Now you can solve an advanced trig function. So this is going to be something you're going to be really feel proud of yourself after second 7.2. Okay, I bet this video going to be long enough, so I've just cut in the pieces. Thank you guys for watching and have a good day, and see you next video. We'll be talking about some more nasty integrals.